At some point in your life, you've probably asked the question, why is the sky blue? And a quick internet search these days will give you an answer to that question almost instantly. And so naturally we move to like harder and harder questions to ask. And so the theme question of the times really seems to be centered around wildfires. And why during a wildfire, during a smoky day, the sky seems to have like a brown hue to it. And so I'm going to talk about how photochemistry and brown carbon aerosols is what actually leads to that. And so to start with that, we need to sort of think more generally about aerosols themselves. So aerosols are going to be particles that find themselves suspended in the air, or suspended up in the atmosphere. And I really like this photo of the campfire in November of 2018 in California because it highlights a few of the main points I want to make. So the first off, the most obvious is going to be the color variation that we see in the smoke plume. So again, the smoke plume is injecting various different types of aerosol into the atmosphere. And so on the northern side, sort of far away from the fire here, we see dark gray or perhaps even black aerosols. So this would be known more of like black carbon. Close to the fire, we see really light gray, really white smoke. So these are going to be sort of just general white aerosols. And then somewhere in the middle, sort of on the south side, we have this like dingy brown region. And this dingy brown region is my favorite because it's the most complex chemically. There's a lot to decipher there. There's a lot that goes on, various chemical reactions and interaction with sunlight. And so the interaction with sunlight is what drives the photochemistry in these aerosols. And looking at this photo, you can imagine that photochemistry might be an important piece just by the giant shadow being cast by this smoke plume. So that's saying that all of the light coming in from above is effectively being blocked by all these aerosols. And different aerosols are going to block that sunlight in a different way. So we'll have three generic aerosols that I just described before, pictured in front, and we'll imagine what happens when sunlight comes in to interact with these. The white aerosol, just like a white t-shirt would on a hot summer day, is going to reflect a lot of that sunlight, effectively keeping you cool, or I guess in the t-shirt example. The black carbon aerosol is going to absorb a lot of that sunlight. And so this is why if you wear black on a sunny day, you can get pretty warm pretty quickly. But the black carbon aerosol, though it absorbs light, it absorbs it uniformly. And so that's the distinction between black carbon and brown carbon, because brown carbon does not absorb all sunlight uniformly. That is to say, it doesn't absorb all colors uniformly. It actually lets a lot more red and orange pass through. And so to understand that, we can take a look at the electromagnetic spectrum. So this is the visible spectrum. So this is what you would see from a rainbow, if you saw a rainbow on a not cloudy day. And so that brown carbon aerosol then, what it's going to do is it's only going to absorb a select portion of this visible region. And that region is going to be the purple, blue, and green. So it absorbs a lot of that purple, blue, and green, purple being UV, ultraviolet. So it absorbs a lot of that ultraviolet light, lets a lot of the red, orange, and yellow pass through, which is what gives that like orange, red, brown hue on a smoky day. And so to understand really what goes on in brown carbon aerosol, we need to break it down to the molecular level. And so when it comes to photochemistry, each different molecule in a brown carbon aerosol will interact with sunlight in a unique way. And so we need to investigate them more thoroughly and on sort of a one-by-one basis in order to truly understand what goes on in brown carbon aerosol.